In this video, we continue our discussion of the mole, which is also called Avogadro's number and is equal to 6.02 times 10 to the 23. This is a huge number, and it isn't very practical to use, as we could never count this many in one lifetime. So we need to relate this huge number to mass, so that we can just weigh our substances instead of counting the atoms or molecules. These white circles are small filter papers that could fit in the palm of your hand. In the first one, we have 1 mole of zinc atoms, which weighs 65.4 grams. This number is on the periodic table as the atomic mass of zinc. 1 mole of carbon atom weighs 12.0 grams. 1 mole of magnesium atoms weigh 24.3 grams. If we go to the periodic table, we can see the atomic masses of the elements that are on the periodic table is the mass of 1 mole of that substance. If you have just one atom or molecule, the unit is AMU, or atomic mass units. But if you have 1 mole of the substance, the unit is grams, and we specifically write it or read it as grams per mole. We call this the molar mass, and it is the mass of 1 mole of atoms or molecules of a substance. The units are written like G/mole, and we read that to mean grams per mole. Let's do some practice. Get your periodic table and add up the molar mass of each molecule written here. I'll do the first one with you. If you look at nitrogen, it has an average atomic mass of 14.01. And then hydrogen has a mass of 1.008. But we want to multiply this by 3 because we have 3 hydrogen atoms in our compound. When you add these up, we get a total mass of 17.03, and the units is grams per mole. Now you find the rest of the molar masses for the compounds written here. Each molar mass can be written as a unit conversion, as I've shown here for NH3. The number has the unit of grams, and the 1 mole is on the opposite side of the unit conversion. Because moles is the bridge between the macroscopic level and the particle level, we don't need to use Avogadro's number unless the problem is asking us to find the number of atoms or molecules in the substance. If we need to convert from grams to moles or moles to grams, we just use the molar mass of the substance in question. Make sure to always do a reasonable check on your answer before moving on to the next problem. If you have a large number with a times 10 to the 15 or higher exponent, the unit should be in atoms or molecules. If the problem was asking for grams and you came out with such a huge number, then you probably did something wrong. The units moles or grams should never be on such a huge number unless the context is of the mass of a planet or the moon. So for reference, the planet Earth has a mass of 5.79 times 10 to the 27 grams. Most of the time in chemistry, we're not talking about the mass of a planet. Let's try this first practice problem together, and then you can do the next one. So we have 4.7 grams of potassium, and we need to convert it to moles. So start out with what you're given, 4.7 grams of potassium. Potassium is K on the periodic table. We want to put the grams, it's the molar mass, on the bottom, 39.10 grams of K, and that is equal to 1 mole of potassium, or 1 mole of K. This tells us we need to divide 4.7 divided by 39.1. And we are left with 0.12, and the unit is moles of potassium. Now you do the next problem. Start out with what you're given, 1.8 grams of water, or H2O. We want to put the molar mass of water on bottom, add up 2 hydrogens and 1 oxygen. We have 1 mole on top. This is how much 18.02 grams of water is equal to 1 mole of water. Then if you divide, we get 0.10 if you round to 2 significant figures. And the unit is moles of water. Convert the following moles to grams. I'll do the first one with you and then you can do the next one. 0.38 moles of PCl6 converted to grams. This time we're going to put the 1 mole on bottom so that the moles unit can cancel. And we're going to add up the mass of phosphorus, 1 phosphorus atom, and 6 chlorines. And that gets us 137.3 grams of PCl6. When we multiply across the top and divide across the bottom, our answer is 52.1 grams of PCl6. Go ahead and try the next problem. Your answer should be 172.8 grams of oxygen. There is no one conversion from grams to molecules. Moles is the bridge between the two of them. So you have to use 2 unit conversions if you're trying to go from mass to molecules. Let's do this problem together. How many molecules are in 1 cup of water? 1 cup of H2O is 236 grams. Start with what you're given. First, we need to use molar mass because we're starting in grams and we're going to get to moles. We need to use molar mass. We're going to put the molar mass of water on bottom so that the grams unit cancel, and we're left with moles on top. Now we use Avogadro's number, but we're going to put 1 mole on bottom so that the moles cancel, and you put Avogadro's number on top. And this unit is in molecules of H2O. So let's go ahead and cancel our units. We're canceling grams of water, and now we're going to cancel moles of water. And our answer is 7.88 times 10 to the 24, and the unit is molecules of H2O. Let's try 2 more practice problems. Here are your answers.